So hey there fellow YouTubers, Frank Bush here again. So in today's video I'm going to be doing another battery review. I had the good people over at the LiTime decided they were going to send me over one of their trolling motor batteries and asked me to do a review on its performance. So you know, I'm not normally a big boat guy, so I decided to mix it up a little bit, and we're going to use this battery to see if I can cook off some french fries like deep fryer style. So if you're interested in how I pull that off, well, stay tuned. Okay, so I've already taken this and opened up the box and stuff off camera. Just wanted to charge up the battery that's in here. Normally when they send lithium iron phosphate batteries, you know, in the mail and that kind of stuff, they'll send them half full or closer to dead than they will to fully charged, if you will. So I just wanted to plug this in, make sure it was fully charged, to make sure that we'd have it ready to go for this video. Yeah, but it's classic high quality stuff that the LiTime sent over, where they've got nice packaging and all that kind of stuff. I'll pop open the little manual here, the product manual, and I'll go through some of the specifics, but really we'll put our focus on getting a deep fryer successfully working where we can make some french fries. I'm hungry for some fries today, so that's going to be the way life is. But you can see it's all good quality packaging. Now, batteries are fairly straightforward. There's not much to them. You've got a negative and a positive terminal and that kind of stuff. So I'll pull this out, set it on the table, and start to assemble things and just get ready for the example. Yeah, so like I say, just kind of quickly pulled it out of the box here. And this has kind of the same performance. I've done a review video for a couple different batteries that LiTime has sent me over, and within reason, this has the same kind of performance, where it's a nominal voltage of 12.8 volts. It's got a rated capacity of 100 ampere hours. You know, the rated energy would be 1,280 watt hours. The charging voltage sits about 14.4. Maximum continuous charge at 100 amps, and maximum continuous output 1,280 watts. So like I say, within reason, this performs almost identically to the other batteries that they sent out with some subtle features. There is some low temperature protection in this, and I wanted to mention that, where if you're trying to charge this battery in sub-freezing temperatures, the circuitry that's built into this is designed to protect the battery and not allow a charge to happen into this battery when it's below zero. It's a way to kind of protect it so it doesn't have any dendrites within the battery, without getting too technical. In essence, if you try to charge these when it's below zero, you can cause damage to the battery. So it's got circuitry built into it to protect that. And one of the other things that this trolling motor battery has is it's got like a high max surge. So when you first get a motor started on a boat, say, yeah, that initial kind of turn of the motor, you know, when it first kind of does its initial turn, it can pull an immense amount of amps, just as the initial kind of 1 second. Really, as a motor gets going, the highest amount of amperage it's going to use is that first initial kind of turn from being stopped, and then the amperage will drop down as it goes into a running mode. So it has it specifically built into this with a max discharge current for 1 second of 500 amps. So you know, that's incredibly good when it comes to motors and that kind of stuff that are going to have that initial high amp draw and then they settle in. You know, if you've got other batteries that don't allow that, potentially you're not even going to start that motor to begin with. It needs those kind of cranking amps, if you will, in the beginning, just to kind of get things going, and then it'll settle into its performance. And if the battery can't handle that kind of draw on it, then it just won't get the motor going to begin with. So it's good in that regard. If I know that there's other people that have done, you know, technical reviews on these batteries when it comes to, you know, is the cold temperature protection, you know, low temp protection, is all that stuff working and all that. I believe Will Prowse did an excellent video in that regard, and you know, all that stuff functions within these batteries. And you know, if you're interested in kind of the techie spec details in that regard, then you know, Will does a fantastic video on that performance on his channel. But for me, it's more about when I'm out in the field, am I going to be able to run this induction cooker that I have here, throw some oil into it and make some french french fries and successfully make some french fries off grid. That's really my target, right? So as long as this battery has enough energy in it to bring that oil up to, you know, a couple hundred degrees Celsius, you know, a couple hundred degrees Fahrenheit, that kind of thing, so I can get crispy brown french fries, that's my primary target today. So I'll pull out my inverter, we'll get all that hooked up, then we'll see if we can successfully make some french fries off grid, yeah? Okay, so had a few delays, so if you guys notice a difference in where the sun's position is, shadows and that kind of stuff, I've just been sidetracked a bit today, but one way or the other the mission continues, right? Let's see if we can do a battery powered deep fry. You know, that is the challenge of the day. So I'm just going to hook up my inverter now to the battery, and the thinking really is I'm just going to connect on my connections to the terminals on the battery here. Just 2 seconds. And when you're making your connections to your battery, you really want to make sure that they're on there super firm, just because you're going to be dealing with large amounts of amperage, and that generates a lot of heat, and if you got loose connections you can have problems. But I've talked about that all in previous videos, and so just when you're hooking on all your terminals and stuff, just make sure everything's, you know, clean and solid, if you will, right? And I'm going to hook on my negative first, and then my thinking really, if you hear noise in the background, I live near a fairly main road, and they've just put in a bike lane, so everybody's kind of eager to take their bicycles down the new lane. But like I say, just make sure your connections are good and solid. I'll connect my negative first, and when it comes to connecting high voltage, this is a 2000 watt inverter. Now when it comes to connecting higher wattage capable inverters up to batteries, generally speaking, I've got this little resistor here, and I picked this up just from an audio shop, but it gives me a high level of resistance, and what it does is there's capacitors in that inverter that this slows down the inrush of current from the battery into the inverter and allows it to charge up the capacitors without throwing any sparks. So using a resistor on the line kind of beforehand, just make sure that I don't see any spark jumps from the battery. You know, I don't want to do damage to these terminals, as there's a massive amount of current wants to rush from here into the capacitors in that inverter, yeah? So I just put on this resistor for a second to kind of pre-charge those capacitors, and it makes it that when I then turn around and say, okay, let's connect the inverter to the battery terminal, that you can see there's no sparks that occur here. It's safe and stable that way. And it's you know, the capacitors that exist in these inverters can be quite large, and the amount of current that can just rush into those capacitors can be quite high, and it'll throw a spark high enough where it can actually do damage to these terminals. Then you definitely don't want to have any of that happening to your gear, right? But one way or the other, we're on good and solid. Those terminals aren't going anywhere. I'll just put the caps on for extra layer of protection, and we should have our inverter hooked up now. And I'll just put away my pocket knife, switch camera angles, we'll plug in the induction cooker and that stuff into the inverter, and we'll start to get this meal cooking, yeah? So like I say, I'm just going to turn my inverter on now. You hear the beep, it lets me know that things are up and running, and I'll plug into here. Now that initial beep you heard is just the induction cooker letting you know that it's connected. And I've got a 2000 watt inverter here. This induction stovetop element can go up to 1800 watts. We're going to try to push it as high as we can at some point along the video, but generally speaking, in order to get up to temperatures hot enough to like heat the oil enough to be like a deep fryer, I only need to run about 1200 watts, which is pretty well what this battery is rated at for its max. We'll push it up a little higher to see if the battery can handle that, but I'm just going to stop now and go cut up some of these potatoes I got sitting in a bag. I'll do that off camera because all this stuff will start to happen pretty rapidly now. We're just going to end up putting this vegetable oil I have into that steel bowl when the potatoes are cut and the oils come up to temperature. We'll throw them in and see if we can successfully start frying, yeah? So before I even go off and start cutting up the french fries, I might as well just get the oil starting to preheat, yeah? So I've just got this steel bowl here, and it's definitely turned a little breezy out here. It was calm earlier, but now the wind started to pick up a bit, so I brought out just a metal grill to kind of cover the top while this is cooking off. Yeah, but I'm just gonna dump some oil now, and this is just basic vegetable oil, nothing fancy here, but just gonna put a half decent amount of oil into this pot now, or salad bowl really, and set that to the side. I'm gonna put this lid on top of it just to stop any debris. I got trees close by, just to stop any of that from getting kind of into the oil. Yeah, like I say, it wasn't a problem when the wind wasn't blowing. But now I'm going to turn on my induction cooker here. I'll come in close and I'll show you the power settings and that kind of stuff on here, so hopefully you guys can see that without too much limitation. Now the thinking really is I'm just going to turn this on, and I go off of the amount of watts being used, so I know exactly how much power. And I've got this sitting on 1,000 watts now, and that tells me it'll reach up to 150 degrees Celsius, so 300 degrees Fahrenheit. Tells me right here that's the temperature that should reach when I'm at the 1,000 watt level. And now that's pushing that battery pretty well, you know, within reason, very close to its threshold. But I'm just, like I say, I'll let this kind of come up to temperature. I'll go grab my little electric temperature gauge after I cut the potatoes, and we'll see how quickly the oil comes up to temperature. But I'll see if I can just shift this back up here, pop this off, and you can see the oil's already starting to be impacted by the heat. Hopefully the camera's picking that up. The induction cookers are really, really rapid when it comes to that kind of stuff. Yeah, but like I say, I'll go cut the potatoes, I'll grab the temp gun, and I'll come back out. All right, so I got a plate full of french fries done up. Hopefully you can see I wasn't shy with that. And I'll just set this to the side now. I give an idea. I'm already at 154.7 degrees Celsius, so that's 310 Fahrenheit. And I started that 5 minutes ago, just to give you an idea. The oil I turned the heat on at 220, and we're at 225 now. Yeah, so one way or the other, we're kind of up to a decent temperature now. And 320, 159, so 160 we'll say. And I want to even boost that up a little higher. Now I pushed it up to 1200 watts on the induction cooker, and to really kind of push this battery to its max. I'll just shift the camera angle a little bit. I'll take a temperature reading. In fact, I'll just pop these off and see if that's hot at all. And these still feel cold to the touch. I'm not feeling any heat there. If they start to get warm, I'll take a temperature reading and that kind of thing. Yeah, but kind of stop and talk about this kind of setup now, where this at 1200 watts, this is about as well. Whew, yeah, that was toasty. But in fact, I'll just put that back on there, make sure stuff doesn't get in there. But at 1200 watts, this is about the peak that this battery should be performing at, and I should be able to run this for about an hour's time. Yeah, when it comes to, you know, this battery will, like I say, I fully charged it right before the video, and I should be able to, at this power setting at 1200 watts, should be able to get about an hour, maybe a little bit more than an hour. But I'm pushing it up to 180 degrees Celsius, so 355 Fahrenheit, and I'm going to give this a few minutes to warm up, because the pot, when we took the temperature reading, I'm reading the metal of this, the steel of this pot. Yeah, and the oil will take the heat from it. But I want to kind of quickly talk about using an induction cooker as a deep fryer in this regard. For people that aren't familiar with induction cookers, this isn't producing heat that's being transferred into the steel pot. That's not how this technology works. There's a magnetic field that exists inside coils that are in this hot plate and surface, if you will, and they stay at room temperature. They induce a magnetic field inside the steel bowl itself, and the magnetic field creates heat because it's flipping and changing the magnetic field in the steel bowl itself. So it's the steel bowl that's getting hot. It's not the stove element coming up to temperature and then passing its heat on. It's in fact the other way around. The steel bowl is getting hot and transferring its heat back to the plate. But part of the reason why this is a safe method in regards is, or far safer than it would be, say, cooking in a pot like this on a conventional stove is, you know, if oil spilled out of this pot and onto this hot stove element, there's potentially a higher risk of fire that could occur in that regard. And in this situation, the hottest part of this whole setup is this steel pot that the oil is sitting in. So the chances of kind of having spillover leading to, you know, fires and that kind of stuff is significantly less. Yeah, it's just way less risky when it comes to that stuff. It's just the nature of how this technology works. And I find, generally speaking, there's kind of a haggle debate in my head. I want to do some full testing, but I believe induction cookers to be the most efficient way to cook food. So I like using this because it's the most efficient way to use the battery energy I have stored. Yeah, and there's kind of a haggle debate for me between using a microwave and using one of these, to which one's actually more efficient. And I might even do a future video on kind of comparing the two and the amount of energy and time and that kind of stuff, but I'll leave that for future videos. But we're at the point now where, let's see, that oil's been on the heat now for 10 minutes, 9 minutes really. So I'm just going to pop this, and I really, yeah, and that oil's getting warm for sure, 100%. But as you can see, definitely enough to kind of get things going. Yeah, so I'll just start to drop in my French fries. And I want to do this nice and easy. I don't want to, you know, have hot oil spitting out everywhere and making a mess out of everything, you know. So one way or the other, I'm going to be gentle with this stuff. But you can see how rapidly I was able to bring this oil up to temperature where I could start to make awesome fries. So really, I'm quite pleased to see the performance that it's working at this level. Yeah, and that was 10 minutes to preheat. That was nothing. So I'm just going to go grab a steel spoon so I can kind of stir this a bit, and I'll put the cover back on so the stuff off the trees isn't blowing in. But I'm already super pleased with the impact I'm seeing doing this. So like I say, I'll grab a steel spoon, I'll shift camera angles, and we'll kind of move on in the video. Yeah, okay. So like I say, I just went and grabbed my steel spoon. And if anybody's curious about me sticking my fingers in there earlier, yes, that was a little on the warm side. No, that wasn't the smartest thing to do, but that's the nature of me being me, right? I'm always being foolish when it comes to stuff like that. But as you can see, we're easily, amply reaching temperatures that are hot enough to be frying these potatoes. And just to give you an idea, I'll just touch this now. That feels about room temperature, and that's cool. Yeah. So I'm not overworking this battery at all. It's able to produce and perform without issue when it comes to things. And I'm already starting to see some browning on these fries. I mean, obviously they'll take a few minutes to kind of come up to speed in that, but it shows you how quickly you can do deep fry stuff. And one of the reasons why this was so rapid, if you watch previous videos of mine, you'll see where, just put that back on to stop any tree debris, right? But if you see previous videos of mine, I've turned around and boiled about the same amount of water, and that took a little bit more time to do. And that's because of the thermal capacity of the different liquids. Water can hold about twice as much joules worth of energy into it before it wants to come up a degree in temperature. So to give you an idea, the oil only takes about half the energy to come up to temperature that the water does. So in 9 minutes it was able to rapidly come up to temperature, whereas the water would have been, you know, half that speed within reason, right? And like I say, I'm not even pushing this battery to its limit. The battery says that I can pull 1,280 watts steady for about an hour, you know, from the specs of the battery, and I'm only pulling 1,200 watts now. So I'm close to the maximum amount that you could pull for this battery, but we're going to push it now and just see, because, well, we can. I'm just going to pop that back off again. It looks like most of the moisture has started to come out of the potatoes now. And this induction cooker is really good at, you can see I'm holding the edge of this bowl with my hand, and it's not burning my hand in any way, shape, or form. The heat is specifically just being concentrated into that oil, yeah, and into the metal that's making contact with the induction plate, nothing more. But we'll turn around and push this up now, and I'm going to go right up to the max. We're running at 1,800 watts now, so that's maximum kind of power draw that this unit would do, and that would push it up to 240 degrees. Oh, so yeah, I just popped my inverter there, because I pushed beyond the capacity of the inverter, I think. Like I say, the setup just powered off there when we pushed up that high. Now it could be the BMS, the battery management system that exists in this battery now, is protecting it. So we'll just give it a second. And I've got everything shut off for the inverter, but we'll just kick this back on here. Yeah, so the battery management system knew that it was pulling too much power. So it shut down the battery from supplying power to the inverter. The inverter could handle it. It's a 2000 watt inverter, and this is an 1800 watt unit, but the battery itself couldn't handle pulling the 1800 watts steady. It'll only do it for about 30 seconds, which is exactly what it was rated for. If you remember earlier in the video, I talked about it can handle a spike of 500 amps in the beginning. So in fact, I'll turn that back up to 1200. We'll even try to push it up to 1400 and see if it can handle being a little overclocked, yeah? And we'll see if it shuts off again. I mean, there's no harm either way. Knowing that the battery management system kicked in, and that's exactly what you want that battery to do though, right? If you're drawing on it too hard and it's pulling too many amps, yeah, see the battery cut off again. So it hits its threshold when it gets up to the 1280 watts being pulled off the battery. In order to protect itself, it shuts itself down. And that really, if I wanted to push up to 2000 watts that this inverter can handle, and the 1800 watts to get maximum power out of this induction cooker, I'd have to have two of those batteries hooked in parallel to each other to be able to draw that many amps at one time, yeah? But like I say, the battery management system protects the battery, and one way or the other we're back on again. And I know that I can't push it above about 1200, which is okay. To 1200 watts still gives me 180 degrees Celsius, or 365 degrees Fahrenheit for the oil, which is plenty enough to be cooking off these fries, right? But it's good to see that the safety mechanisms of the battery kicked in and did exactly what they were designed to do. You know, you don't want to have it where the battery doesn't have that overcurrent protection, which is exactly what that is, yeah? Doesn't want to have that overcurrent protection built into it, because you can destroy your batteries by trying to hit them too hard and draw too much power off them. But we'll see now. We're at 12:36. So it's been 16 minutes since I turned the power on initially, and my fries are already starting to come along. I'll shift camera angles and see if I can get you a good angle on these fries. They definitely need a few more minutes on them still, but one way or the other, we're making headway. So that's about as close to the french fries as I want to get my camera without worrying about, like, am I going to damage my camera? But you can see it's pretty rapid. I'm already starting to see some browning on those fries. Hopefully the camera's picking that up. Still has a bit of a ways to go, but we'll run this through its whole process to get nice golden brown french fries. You know, I'm not going to chintz out on this detail, but to give you an idea, like I say, I could run this until about 320, and we're at 220 or 238 now. So I could still run this for about 40 minutes or so before I'm expected to even run out of power here. These fries will be cooked off well before that. So to give you an idea of, I could probably do off 2 batches of french fries just off of a single charge of battery, you know? And I've shown in previous videos how you can hook up solar charge controllers and that kind of stuff to refill these batteries up. But I just really wanted to see if I could push this battery kind of to its edge, which is what we're doing now. At 1200 watts, we're pushing it up to just below what it's rated at. Like I say, it's a 1280 watt max is what you're supposed to be drawing, and we're drawing 1200. So we're, you know, we're right up close. And I'll just pan the camera back a bit, give a temperature feel of these terminals. Still feel cold. So I'm liking that. In previous videos I've done where I cooked off a bunch of chicken using an electric grill and that kind of stuff, and I was using, I think I was using their mini battery, and the temperature was starting to get quite warm on the terminals. I'm not seeing that problem exist with this trolling mortar. If you can see, I'm at 21 degrees Celsius for the trolling mortar terminals, so 69 degrees Fahrenheit. They're, you know, room temperature. They're not really any risk of being overheating or any of that business at all. So I'm kind of pleased in that regard of that I can push this battery pretty well up to its max, you know, and not have it get really hot on the terminals and that kind of stuff. That's always, in my mind, always a good safety feature. And like I say, when it comes to this element, you can see, look, I'm putting my hand right on, hopefully the camera's seeing that. Here, I'll pan back down again. I got my hand right on that stove element, if you will. I'm not burning myself. The heat is all just in the steel pot. And that's one of the reasons why when I'm doing off-grid and solar technologies and stuff, I prefer using either induction cookers or going down to 12-volt cooking material, where I've done multiple videos in the past of using 12-volt systems, just because of the efficiencies. I think induction cooker is about 90% efficient. So, you know, the amount of power you're pulling out of the battery, you can get about 90% of that directly into the food you're cooking. That's unmatched if you had a little 1,000 watt, you know, camping stove burner or that kind of stuff. I'd be drawing the same amount of power I am with this, and nowhere near the efficiency. And I'd have a higher risk of, you know, fire hazards or the hot oil spitting out and that kind of stuff. In fact, I'll just leave that off since I'm here tending to it. But you can see these fries aren't cooking super fast, but they're definitely just starting to get some brown to them, yeah? So like I say, right now it's 2:41. So we started this 21 minutes ago, and I'll let this cook for a few more minutes and I'll cut back and show kind of where we're at in relationship to the time, to how fast this will be cooking, yeah? Okay, so I just went and grabbed my multimeter. I'll set this down here, and we'll just see what the voltage of the battery's at right at this point. So I'm still sitting at 12.44 for the voltage on the battery. Hopefully the camera's seeing that. So this battery's not having a hard time, you know, handling the 1200 watt load that's being applied to it. You know, it's able to deal with that easily and not drop voltage anywhere into a danger zone where the inverter wants to turn off from low voltage or any of that business, right? So you can see this level of setup can easily handle doing deep fry. So one way or the other, I'll shift camera angles again. We'll go back to those fries, make sure we don't burn them. Okay, just put the multimeter back now. Hopefully you're able to see that. Of these fries are starting to get pretty brown now. So they're definitely to the point where I consider that to be cooked. And that's at 2:44. So it took 24 minutes to get to that point, yeah? So I'm gonna drop that. And didn't really think this part through too well, but I got drain holes in this tray, so hopefully the oil will just go back in. But I'm not worried about oil dripping and stuff too much in that regard with this setup, because like I say, I don't feel that the induction cooker is going to create a fire risk for me. It's just not the nature of how these, you know, these pieces of equipment do their cooking. You know, it's just the way it is, right? So I'll just set these onto this plate now. But you can see, in less than a half hour's time, I was able to have, in essence, off-grid French fries. And generally speaking, what I do now is just wait for that oil to cool down a bit, put it back into like a glass mason jar or something I had stored, just to store it for the next batch, and just treat this as my French fry oil, yeah? Now I can see that the unit shut down again, and I'm not sure exactly why. I might have accidentally had it set up too high, but yeah, no, everything's still working. Maybe I just turned it off and didn't pay attention to what I was doing. but hopefully you can see that. I got oil all over my hands now, but let's see now. I'll just twist you this way and drop you down a bit. I mean, tell me those off-grid French fries just aren't top shelf, right? And that's a full plate of them. This isn't a small size plate in any, you know, stretch of the imagination or anything. I'll try one out and see. Oh, it's hot. Tasty though. And you guys can see, it's got browned well and everything else. There was no issues with cooking this. I should still have about half the capacity of this battery left. Just because, like I said, I should be able to run about an hour's worth of time. I'll just turn off my inverter because there's no sense of wasting the energy. But, you know, with everything said and done, I should be able to run this trolling motor at the 1200 mark. I should have been able to run that for about an hour. And we were less than a half hour to get to this point. So, there you have it. And I'll just take temperature readings on everything else. So that oil was sitting about 300 Fahrenheit. 148 Celsius. Gives you an idea of the temps we were dealing with. I got oil on everything now because I'm a savage that way. And when it comes to these terminals, they're still room temperature. They didn't even get hot. We didn't even really push this battery to its limits. Now I know I'm using this trolling motor battery not for its intended purpose, but it was more just wanting to test, okay, putting it under significant load. And I could see that if it was able to handle running that 1200 watts for the half hour without issue, then it just becomes a capacity of the battery. And from all the tests I've seen online, when it comes to this battery, the depth of capacity isn't an issue. That nobody I've seen has had any problems with that. So I'm quite pleased with this trolling motor. I like the fact that it can do that 500 amp spike if it's, you know, a motor just starting off and that kind of thing. And I like the fact that it has that low temperature charging protection. So, you know, if you're in icy conditions, it just won't allow battery power. It won't allow energy, like from your solar setup or whatever. It won't allow that to go into the battery if it's below freezing, because that would do damage to the battery. So it has the circuitry built in to kind of protect it from that kind of stuff, yeah. But I'm going to stop for 2 seconds and start to eat off some of these French fries, because, you know, the smell alone is just getting me. But I'll cut back in 2 seconds and we'll start to wrap this video up, yeah. So yeah, there you have it, fellow YouTubers. Being able to do deep fry off-grid isn't really that challenging. It's just having the right technology that allows you to do it efficiently. That to me is the key. If I wanted to do this with conventional like stove elements that you'd have, it would be very difficult. The temperatures wouldn't come up to speed as fast. I'd have more of a fire risk. Just using the induction cooker, you know, this cooker stovetop, makes it far safer, and it makes it far more energy efficient. And when it comes to any type of off-grid application, you know, having a solid battery like this trolling motor would be top shelf. It's something, you know, you'd want to have something to this scale that allows you to do these things. And I've shown in many previous videos of, to fill this back up with a solar charge controller and some solar panels strapped onto it is a no-brainer. It's not a complex thing to do. But I do like how I can break this off and just have it where I don't have my solar stuff. If I wanted to just go off and cook some French fries and chicken or something when I was out at the beach or whatever it was, I have the ability to do that in a fairly small, compact space, right? Like I say, I'm not going to keep rambling because I want to eat these fries before they get ice cold. But if you enjoy this type of content, please like, share, and subscribe. And thanks for watching, yeah? Cheers. Figured I'd show them one more time before I eat them all. Like I say, thanks for watching the show. Hopefully I'll have more coming soon, yeah? I've got a whole bunch of videos lined up in the pipe. It's about a half a dozen different videos or more that I want to do. It's just getting the time to do them, yeah? I tend to be a fairly busy guy, so finding times to peel off, you know, 5-6 hours to do the recording and then do the editing and all that stuff, right? It just takes time. And like I say, when it comes to this LiTime battery, as everyone they've sent out to me. They've all been rock solid. I'm really impressed with the LiTime for the cost and the quality and everything, the shipping, the the battery's longevity, the depth of capacity, the capacity that it has to run large amounts of wattage out of them and all that kind of stuff. I mean, for the price point, I don't think they can be beat, and for in comparison to the quality and all that. So if you're looking for a good kind of high quality lithium iron phosphate battery that you want to use out in the field, definitely consider LiTime. In my mind, they're definitely one of the better options to go with. Yeah, like I say, thanks for watching. Cheers.